I've got 5 input devices for you to look at. 2 temperature related, hence the Bunsen burner. 2 light related and 1 sound related. Just to say from the outset that an input device is an input device because it takes some form of energy, and with regards to this video it will be either heat, light or sound, and converts it to an electrical signal. So for the heat, I've got 2 devices. One of them is what's called a thermocouple, which is here. Now all the thermocouple is 2 pieces of wire, 2 different pieces of wire, sorry, that have been wrapped together and either end connected to this little holder. Now, at the moment, voltage produced practically 0. I put it in the Bunsen flame, the orange yellow flame. You can see the voltage, the temperature dependent voltage rises up to about, well, reasonably slowly, but up to about 20. However, I put it in the much hotter blue flame and you should see a much quicker rise. And it is. Going and going and going, glowing red hot. I'll take it out. And as it cools, the voltage continues to drop. Now, that's the thermocouple, that's for extreme temperatures. So for example, in an oven. This is the little device, what you can see it sticking outside is an LDR. Sorry, it's a thermistor, not done LDR yet. It, at present time, is registering it's not the best connections, it keeps, there we go. Registering a bit around 1,500 ohms. However, just by placing my fingers on either side of it and heating it up, the resistance falls. So for this thermistor, as the temperature goes up, as the temperature goes up, the resistance drops. Now, turning round, the light section. So what I've got here is solar cell and an LDR. The LDR standing for light dependent resistor. Now here is a voltmeter that's attached to the solar cell. And as you can see, just by background light in this room, it's about 1.25 volts. However, increase the light level and the voltage increases. Hopefully you can still see that, is now it's 2.5. So decreased light, decreased voltage, provided or supplied by the solar cell. On the right hand side is an ohm meter, which is measuring the resistance of this LDR. So in just normal classroom light level, it's registering 2,240 ohms. Increase the light level and the resistance decreases. So for the LDR, the light dependent resistance, as the light level drops, the resistance increases. That takes us on to the final input device, which is a microphone, which I have here. One karaoke style microphone. Is it on? It is on. Now what it does, you can possibly see already that it does produce an electrical signal which is picked up on the oscilloscope. I'm going to demonstrate by whistling into it. See if you can name the tune. And as you can see, convert sound energy into an electrical signal.